Hello, everyone, and welcome to today's webinar, Preparing Your Website for the Google Page Experience Update, Why It Matters, and How Varnish Can Help. Before we get started, I'd like to go through a couple of housekeeping items. There you go. So today's webinar is being recorded and will be distributed afterwards to everyone who registered. Feel free to ask questions throughout the webinar. There is a panel on your screen for a Q&A for any questions that you have, and you can also use the raise your hand feature to ask your questions. So what we'll do is we'll call on you if you do raise your hand and you can ask your questions live. For today's agenda, we'll start with some introductions. We'll talk about what the Google Page Experience Update is, why it matters. We'll talk a little bit about Google's Lighthouse tool, and then go through the ranking features, kind of what each one means and how Varnish can help with those. And again, like I mentioned, we'll finish with a Q&A at the end. So I'd like to start with today's speakers. I'm Alexandra Barcelona. I'm the US Marketing Manager here at Varnish, and I'll be moderating today's webinar. We have Andrew Wick, who is a Varnish core engineer, who will be going through all of the technical information on today's webinar. He is a great resource, so I do encourage you to ask questions throughout the webinar for Andrew.
Hi guys, so let's get started. So the overview. So Google in May, now at June, they pushed it back. Will be introducing a new ranking algorithm that is supposed to determine how fast your site is to the user. And the main reason they're doing this is because users want to visit fast sites. So how they determine this is if the page loads quickly, is it secure, is it mobile friendly, is it spammed with ads, and does content jump as the page loads. So let's move on to why it matters. We sort of already went over this. Google wants to direct users towards fast sites because users want to use fast sites. They don't want to go to a site that's slow and laggy. So how do they determine if a site's fast? So they have actually developed a in-house tool called Lighthouse that anyone can run. It's actually built into Chrome, and that's how they do it. And they call this your page speed score. So the reason they provide this tool for you is so that you can measure, but it will also tell you which specific parts of your website are slowing the page down, so that you can change that. So what are these metrics? So the first one is your FCP, referred to as your first contentful paint. So this is how long it takes to load the first elements on the page. So this doesn't mean everything inside of that orange box, but it does mean some of it. So maybe you start loading the image up here. Maybe you start loading the logos, something. You have to be showing users something. So how can Varnish help in this area? There are a ton of ways. I've highlighted the top 5. So the first is full of page caching. So that means taking the entire page and then putting it into cache. Putting into cache means that when the user loads that page, they don't have to go all the way to your backend server, and then your backend server has to spend time building the page and then sending it back. They can get the page pre-built directly from a Varnish, and that usually can bring down your page load if your backend's really slow, even by 5 seconds, depending on how slow it is. So the next is resource prefetching. So this is if you have images, CSS, which is what makes the page look pretty. JavaScript, that's what makes things happen when you start clicking. You can tell the browser, hey, I'm going to need these assets. Start loading them as soon as I request the page. Normally, it would have to wait until the page has all of the HTML to look it through and go, hey, I need this image, this file, this file. We can actually tell the browser using headers. So the next is compression. So I'm sort of like you like formats like JPEG, PNG, all of those. There's actually a compression format for a text, which is like HTML, and that's called Brotli. There's also gzip. All you really have to know is that Brotli is the newer, faster, smaller one. And the reason this matters, especially for users that are in more rural areas that don't have blazing fast internet, they need to download the smallest files possible, and that's what compression does. So the next thing is HTTP2. What this does is that it lets you load multiple assets simultaneously, and it allows you to load more at the same time too. So this is useful if you have lots of assets, like lots of images, lots of different like JavaScript files. Being able to load those really fast is really important. And the last is dynamic page stitching, which we will get into later. So first, prefetching on HTTP2. So if you want the browser to prefetch, you can do it in two ways. The first, which is the older way, is that you can put prefetch tags in the HTML. But this really doesn't help that much because the browser still has to get all the HTML and parse it and then pull all of those links out. The best way is to actually define it in a header. That way the browser doesn't have to start parsing HTML to start loading those assets. So if you look in the gray box here, you will see that's an example of what the headers would look like. So the first is the asset link. Then it's the what you want to do. It's usually preload. There's one other type called pre-link, which is you can do the DNS lookup beforehand so that part's already done. And then next, you just have to tell it what a type of asset it is. So the reason that you have to tell it what a type of asset it is that browsers like Chrome, Safari, Firefox will actually go, hey, we should probably load a CSS first, then the images, then the scripts. So it'll automatically prioritize all those things. So HTTP2. So if you see the scratch on here, first there's HTTP1. So in HTTP1, you need one connection from every single asset. Now, this was great when the web didn't have any encryption, what you see as HTTPS, because there was no overhead on making more connections. But now with encryption, you have to first do a handshake, which basically says, hey, here's my key, and then the server goes, hey, here's my key. So if you do that for every asset, that's going to slow down the page because those resources are going to take longer to load. So what you do with HTTP2 is that you can actually do that handshake once and then pass multiple assets over that line. And that's really important because as encryption gets more secure, it inherently usually gets slower because you have to do stronger encryption. So the next is dynamic page stitching. So if you're running something like a e-commerce website, which is the example here, you might have the user's name in the top. You might have their cart total. You might have tons of different personal information. So the problem is if you cache that personal information once, every user is going to get the same personal information, which is not great because that's a security risk among other things. So what you can do with Varnish is that you can say, hey, cache this part of the page separately per like a user. So then we can still cache the huge main part as a separate piece, and then have the backend only build that personalized part once for each user. And then let's say the user changes their name or they update their cart. You can just purge out of the cache just that small a piece of the page, not the in a type part of the page. So there are a couple ways to do dynamic page stitching with Varnish. The first is ESI, so that stands for edge side includes, and that's something you would have those tags. Your backend serve those tags, and then Varnish would do the stitching. One of the differences between open source and enterprise is that open source does the stitching one by one. So if you have multiple fragments, it's the way for the first one to be done, and then do the next one, and then the next one. Varnish enterprise does them all at once. So if you have multiple, they're all started at the same time. So the second way is Varnish can actually pull out the parts of the pages itself and then store them as a separate without you making any changes on the back end. And this is useful if you're not as a technical savvy company and you're using some type of pre-built solution or a platform for your website. So what's the next metric? That's the largest contentful paint. So this is when about 90% of the content in that orange box has loaded. So this will always be larger than your first because your first has to be lower because that's when things just start loading. This is when stuff is done loading. So how can Varnish help you? So caching images. So instead of going to your backend for every image, you can have a Varnish serve them. Another one which is really cool is in aligning images. So what you might not know is that you can actually base a64 encode image and then put it in the HTML, so in the page. And the benefit of doing that is the browser doesn't need to make a separate request to get that image. But there's also some downsides. Your HTML is going to be larger because now it has those images in it. But normally, if you have smaller images, it's a more beneficial to inalign them. So normally, this would be a painstaking process on your back end, come like converting my images to a base of 64, then inserting them there. Plus, also, if you don't have control of your backend in that way, you may not be even able to do that. What Varnish will do in the future, this feature actually just wrapped up the encoding yesterday, and now it's going into testing, is that we can actually do that base 64 in a coding and that insertion into the HTML on the fly, so that you don't need to worry about that. And one thing that we're also playing with is dynamically doing it based on the size of the image. So you won't even need to go and pick, hey, I want this one, this one, and this one to be in line. Varnish will just magically go, hey, these are the ones that should be, these are the ones that shouldn't. And then also the same pre-fetching your assets and the HTTP2 are huge things. One other thing is that you can also ESI in actually JavaScript and like a CSS. So instead of the page having to go and make a separate request to grab those files, they can already be embedded in the page. But you can keep them as separate resources inside Varnish so that when you, let's say, change like a JavaScript file, CSS file, you don't have to purge the entire cache. You still get the benefit of that looking like a separate file. The so if we go next, so time to interactive. Time to interactive is how, sorry, I had noticed my video froze there. Is how long before the user can start clicking, scrolling, interacting with the page. This is very important because let's say on that first paint, it's just an image. There's no text. They have to scroll to get to the text. They can't start scrolling until this is done, or at least according to Google. This metric is a little iffy sometimes. So how can we help here? We can cache the JavaScript because JavaScript is the main thing that will affect your time to interactive score, because that time to interactive isn't going to end until all your JavaScript is done executing. And something that JavaScript may do is that it may call out to a API to load additional information onto the page. So what we can actually do is cache those API requests so they return faster, which then means you get your JavaScript execution done sooner. One thing that you can also do is that you can actually partially render those API requests into the page, so you don't need to do that separate request. And you can use this doing enterprise features we call Xbody and Edge Dash. Another thing you can do is that nowadays you throw in 20 different JavaScript libraries into your site, and now that's 20 different requests the browser has to make to go get all those files. You can actually use ESI to combine those smaller JavaScript files into one larger one, which is more efficient for the browser to load. So the next thing is, how do we cache in API requests? So usually when you cache something, you have to base it on the URL or the headers. This usually won't work for an API request because these are posts, and posts have bodies, and the bodies might say, hey, I need to get the image links for this product, or I have to get the pricing. And normal caching won't be able to do this. But what we can do in a Varnish is we can actually hash that a body and then base the cache key off of that body. And this is very important, because if you can't do that, then you can't really cache those post requests, because you would be essentially ignoring the body. So this is a VCL example. So first we check, hey, if it's this URL and it's a post, we then want to take the body, put it into cache so that we can hash it. And then we also need to save the method, which is the post, because we have to set that back later. Then we go, hey, because we're looking at the cache, Varnish expects it to be a get. We have to tell it, hey, no, we're actually going to do a post. And then, inside of the hash function, we say, hey, add that hash that we computed earlier to the cache key. So the next is your total blocking time. This is how long the CPU takes to process and execute the JavaScript. This can sometimes be longer if you have really slow JavaScript or really inefficient JavaScript. There's not much we can do here, but if your JavaScript is rendering things from the API, we can possibly run those with Varnish inside of Edge Dash, so we don't need to do that inside of the browser. So cumulative layout shift. This is how much elements sort of shift on the page as the page is loading. So a great example is usually when you visit new sites. Those are no tourists for being really slow to load. And then as they load, the text jumps up and down the page, making you lose your spot, which is really annoying. Google thinks so too. So they account this into your score. And they call this the CLS. So how Varnish helps here is by, if those assets get to the browser faster, the browser is much less likely to have the page have to jump, because those resources will be already loaded into the page. So doing all these things, how does this help us? So I actually have a example here of a customer we worked with recently. They came to us worried about this Google page experience and how their site was going to be ranked, because their scores weren't great. So after implementing all of these and a few more, they actually got to 100 and have all their scores green. So I can sort of break down how much each of these 6 scores contribute towards that at 100 points. So your total blocking time, that accounts for 25%. Your cumulative layout shift accounts for 5%, so not that much. Your first contentful paint counts for 15%. Your largest contentful paint, I believe, is 25, and I forget the speed indexes. It may be another 15. But so really, those total blocking times and those paint times contribute 60 to 75% of your score, and that's huge. Getting your CLS low is usually pretty easy, so that's not a big a deal. Your time to interactive, Google is letting that slide a little bit for now, but rumors are they will count on that more heavily in the future as well. So you also want to make sure that you can get that down. So, questions. I see we have one from Michael. So Michael asks, will these tools, caching images, fetching assets, etc., be useful for smaller content sites like blogs? So yeah, huge for blogs. Blogs are usually image heavy, and depending on what you're using to render your blog, your pages could be rendering really slow. A great example of a engine that's sometimes not so fast is a WordPress, and WordPress is used for blogs all the time. Now, if you have static blogs like ones built with Ghost, these can also be improved because your server is always going to be slower serving the content than a Varnish, because Varnish is solely built to do this one thing, and it's built to do it really well and really fast. Your blog engine has to do multiple things, so it can't do that one thing as fast because it also has to worry about everything else. So the answer is yes. Video sites, huge, because Varnish was built for a video. We have customers like Netflix and Sling, and then also Hulu, I believe, is also on there, and they serve vast amounts of video. By caching that a video, and a Varnish can handle terabytes of a cache, so they can cache all their video and then never have to hit their backend server and then serve that video really fast. So the answer is yeah. Even small sites, large sites, video, Varnish will help in like all of them. Now these solutions for like which of those techniques may be different, but Varnish has different techniques based on the different content.
All right. Thank you, Andrew, for that. We did have a couple other questions come in as well that I'd like to go through, but do want to remind everyone again, you can either post your questions in the chat, in the Q&A box, or simply use the raise your hand feature and ask your questions live. We also do want to mention, if you are interested in kind of seeing everything that Andrew went through today, but on your own site and how it can really improve what you have currently going, do feel free to reach out to us at this email, and we will get you set up with a custom demo and kind of show you very customized what it can look like for your own site.
And I was so that everyone building those demos.
True. There you go. Andrew will be doing it himself. So the next question we have is, how long after I make these changes will I see an improvement in my Lighthouse score?
Yeah, so you make these changes, you'll see an improvement in your Lighthouse score right away. You can test your Lighthouse score. Google will generally compute your page score about once a week. And you're thinking, why not every day? And the reason for this is because there's billions of websites, and Google only has so many servers, so they can only scrape so many sites at a time. But Google will really start relying on this Lighthouse score a lot more in June. Now, you may have ran a Lighthouse score maybe a few months ago and done great. That was Lighthouse 5 and 6. So the actual change that Google is doing here is that they're basing your score now on a Lighthouse 7, which will require your scores, like your times, to be a lot lower to get higher scores. basically they're being less lenient now with it. So by testing again, you can really see, hey, am I doing good? So you really need to test two things. You have to test your score on desktop, so like laptops, that type of thing, and then also on a mobile, so phones. So desktop, Google generally will want a 90 and above to rank you anywhere good. For a mobile, it's a lot harder. So they're a lot more lenient. Usually if you have a 70 and above, they'll be happy. Because getting mobile to 100 is unlike unless your site is really small and like most of the content is static, you're normally not going to get there. So that's why they're more lenient there, because they base those mobile scores on someone with a 5-year-old phone accessing it on a 3G network out in the middle of nowhere. And that's really not the case anymore. Most people have newer phones, they have faster internet, but Google still wants to make sure people in those parts of the world still have a great experience on your site, which is why they enforce those slower speeds.
Makes sense. Thank you, Andrew. Another question that we have is, can I make these improvements using the Varnish open source, or do I need the enterprise version?
Yeah, so some of these you can do with open source. That's fine. But any of the more complex things, you really need enterprise, because you need those custom vmods to do those things. Examples of this are caching those API calls, aligning those images, doing that more complex ESI, doing like any of that page like stitching if you like want it to be fast. All of those things you really need to run enterprise, because that's all built using our custom vmods. Also, if you have a really large site with like hundreds of thousands of pages, you need a large cache, and for that you really need enterprise, because enterprise you can start using disk like and VME SSDs for that cache storage, so you can have gigabytes to a terabytes of storage, which might be really important, especially if you're a video heavy site.
Perfect. So looks like this might be one of the last questions is, what percentage of improvement can I expect if I make these changes? I know you showed the before and after just on the slide before this, but kind of what is the average that people can expect?
Yeah, so
if they do make
I'll
these
be quite honest, it all depends on where your site is now. If you're scoring a 23, chances are you're going to see like 300%. If you're scoring like a 70 or 80, you're not going to see as large of a improvement. Your site might already be pretty fast. So really slow sites, you can see anywhere from a 3x like a 10x even. And like I said, that all depends on how slow your site currently is. If your site's already pretty good, you might only see like a 50% improvement, 100% improvement, but you always will see some improvement. You will never go the other way.
Well, that's good to know. Okay, I think that's all the questions that we have. So we can wrap it up here. Again, if you have any other questions, anything that comes up, please do feel free to reach out to us. And if you would like to see this, kind of have Andrew go through it for you on your own site, you can just shoot us an email. Andrew, if you want to go to the next slide, I think that had the contact information on it. So you can go ahead and reach out to us there, and we can make you a custom demo. Again, this session has been recorded. Once it's done rendering, we'll send it out to everyone who registered, and feel free to reach out to us again if anything else comes up. Thank you so much for all of your time, and thank you, Andrew, for this presentation. And we will see you guys on the next one. Thank you so much.
Thank you so much, guys.